So chapter 3 in our book is flow of control. And when I talk about flow of control, it means in your program, how your program runs. And so far inside of our programs, our flow of control has just been a linear kind of flow. We start at the beginning of our program and we go to the end and then we stop. Okay? So it's the order in which a program performs its action. A branching statement allows us to add some intelligence to our program because we're going to be able to choose between two or more possible statements of code to execute. And then I do have a bullet point in here that says a loop statement repeats an action until a stopping condition occurs. We're not going to cover loops this week. We'll cover them in a couple weeks. But those are your three things that you can do with flow of control. You can either have a statement, okay, and a statement is like a variable declaration. This is a statement. A statement is something that usually ends in a semicolon, and it just does something in your program. Okay. All the programs we've written thus far have just been a bunch of statements. And the statements run sequentially, so it starts at the beginning of your program, comes to the end of your program, and then stops. Programs would be pretty boring if that's all they did. So a branching statement allows us to do something under a certain condition. Okay, so with these three flow of control things, so a statement, a branch, and a loop, all of your programs in the world are written. So all of the logic for Microsoft Office, all of the logic for all of your games like Halo or Destiny or any of those games out there in the world, they're all created with statements, branches, and loops. Okay. Yes, they add object-oriented design and a little bit more abstract ways of programming on top of it, but the underlining logic is always statements, branches, and loops. And this goes for any programming language. So once you learn how to make a statement, a branch, and a loop, you'll be able to take this knowledge and move to any programming language. All right. Here's a first look at a branch and what a branch looks like. I bet you can read it because it makes logical sense when you look at something like this. What do you think this branch is doing? Just by looking at it, you can kind of tell what it's doing. Okay, if x, variable x, which isn't a very good variable name, but okay. But if this variable x has the value 10 inside of it, or x is equal to 10, then we print out the line x is equal to 10. Otherwise, we print out the line x is equal to something else. So you can kind of tell how a branch works just by looking at this. Okay. If something is true, then you do this line of code, and if that thing is false, then you do this line of code. Okay, this thing in parentheses is called your Boolean statement. A Boolean statement has to be either true or false. There is no maybe. Computers have no gray area. Okay, they're either black and white, on or off, 1 or 0, true or false. So something either has to be true or false. So if it's true, you would do one line of code, and if it's false, you do the other line of code. And that's, in essence, how a branch works. And then just a heads up, when we start getting to loops, this is how a loop works. Okay, you have while loop and for loops. But loops let us run lines of code over and over and over again until we tell them to stop. Okay. A lot of times in a lot of books and tutorials, they'll say to think of a branch kind of like a fork in the road. You either take the right path or the left path. You can't take both paths. Okay, you have to take either one road or the other. Okay, so you're either executing statement 1 or statement 2. You can't execute both of the statements. Okay. Here's another example. And this slide looks a little messed up, but we'll assume that count is equal to 5 and total is equal to 1. So here's an if-else statement. So we're either going to execute this line of code or this line of code based on what count is. So whenever you see code like this, I say plug in the numbers. So plug 5 in here and see if this is true. If 5 is less than 3, is 5 less than 3? Let's hope not, right? We all took Math C. We have to add Math C to get in here. So we all know 5 is not less than 3. So we all know that total is going to equal total plus count. And we're not going to get to this line of code. We only execute the else part, or this line of code. So what would it print out? If count is 5 and total is 1. Right. It would put 6 and then the numbers are a space and then 5. 5 for count. So total would be 6 because total equals 5 plus 1. So it equals 6, and then we put the white space, and then it would print out count, and count happens to be 5. What would be something that would make this false? I mean, make it true, sorry. We already saw making it false. What would make it true? Yeah, anything less than 3. It could be a 2 or a 1, or if count was negative. Okay, anything that would be less than 3 would make that true. So pretty easy. I guess we can try it. It says code an if-else statement to check to see if a number inputted by the user is less than or equal to 5. Okay. And I'll code this for you. All right. So let's say a number inputted by the user. Okay, so kind of a little review. You guys do not have to follow along with me on this one. You guys can just watch. Okay? I'm not going to make you guys turn this one in. But remember, we need our keyboard object to get a number from the user. Okay. And then we use that keyboard object to get that number using next int. Okay. And let's say my number was called number. Okay. Now how would I write that branching statement? I would write number, and then my specifications are what I said. Check to see if a number inputted by the user is less than or equal to 5. So what would I put in my Boolean statement here? I know we haven't gotten to the comparison part, but if I wanted to check to see if something was less than or equal to 5, well, what could I put? I could put less than or equal to 5 like that. I think that's what he was getting at. But what if I just wrote less than 6? That would check to see if something was less than or equal to 5. So remember, if you can do less than or equal to 5, something less than 6 is less than or equal to 5. So there are lots of ways that you can write this. So you can either write it as less than or equal to 5. And that would be the same logic as saying less than 6.
Would that only be because the number is of a variable int?
Yes, so I'm checking it against integers.
But then it would be 5.9.
You would actually could check if it's less than 5. A lot of programmers would say don't ever check doubles inside of a Boolean statement because doubles can be incorrect. Because remember how a computer kind of messes up doubles sometimes? Sometimes they'll say don't ever check a double inside of a Boolean statement. But let's say that you did make it a double, because I do see programs like this in the world. You can say less than 6 and it will check it correctly. You can say less than an integer value. It will check it correctly. Now, of course, you would have to do something after this if statement. So we could say less than or equal to 5. And just to show you how this works, you know, we have not written a program in here that doesn't have any output. So remember, if you don't have any output, you have to open up your console yourself and put that in there. Or output in the beginning of our program. All right. Is that kind of clear? If statement, pretty easy. And this leads actually to the next slide. You can have an if statement without an else part. Good question. I had a question. He said, what if you gave it the wrong type of input? What if I gave it a letter like the letter E? What if I put the letter E in here? And yes, it does a type mismatch. And where it's failing is right here. I'm saying get the next integer. And Java's very type safe. And so it says, hey, that's not an integer. And actually, that's called a runtime error. Remember, that's our runtime error? So our program was compiled, it ran, and then it crashed. So when we give the wrong input in Java, it does crash. If I give the wrong input in some other programming languages, it won't crash, actually. But it does in Java. Good question. Now that little blurb of code kind of led us to the next slide here, and you can have an if statement without an else part. Now also, when I wrote my if statement, notice I did not put curly brackets around the parts of the if statement that we're executing. I did not put a curly bracket here and here. Though if I did, it would be okay to put a curly bracket there and there. And the reason being is because this if statement only had to execute one line of code. And when a branching statement only has one line of code after it, you don't necessarily, it's optional to put the curly brackets. Now, if an if statement has to do two things or two lines of code, two statements, let's say it has to set these two variables both to 0, so that's two statements. If I'm executing more than one line of code, then you have to put the curly brackets in. And this is called a block statement or a block of code. So if this if statement is true, it executes the entire block of code. That makes sense, right? So if I'm executing one line, I don't need the curly brackets. If I'm executing more than one line, I need the curly brackets. And it's called a block of code. And then importantly, you don't have to have an else part. You can have an if without an else, but you can't ever have an else without an if. That doesn't make sense. Okay. Here's another example. Now, if statements and while loops both use something called Boolean expressions. And like I said before, Boolean expressions are either true or false. And here's our comparison operators. You saw me use the less than or equal to operator. But here's our these are our 6 operators we have in every programming language, as well as even in math. These are our 6 operators. So we have the equal to operator. Now the equal to operator, because the equal sign is no longer an operator, we use the equal sign in Java as the assignment operator, right? To assign whatever's on the right-hand side to what's on the left-hand side of the assignment operator. So we needed a new symbol to check if 2 values were equal to each other. So the symbol they used is 2 equal signs together with no white space in the middle. So if I wanted to check if balance is equal to 0, I'd put balance equal equals 0. Or answer equal equals y. Okay? If I want to check if 2 values are not equal to each other, I use the not operator and the equal sign together, and that's one symbol, or one operator, the not equal to operator. Greater than, of course, is the greater than symbol. Greater than or equal to is the greater than and equals symbol together. Less than and less than or equal to. There's only 6 of them. You should remember them. Now this slide looks kind of messed up in PDF form. But over here on the left are what we call our truth tables, and I'm introducing 2 more logical operators that we're going to use, the AND operator and the OR operator. Truth tables are the basis of all computing. Okay, and the basis of all of what your computer is built upon the logic of these truth tables. They're pretty easy to understand too. Okay? We use these kind of operators to check to see if 2 Boolean expressions are equal to each other. So let me skip down here really quick and we'll go back to the truth table. So what if we wanted to check if score is greater than 0 and score is less than or equal to 100. So in other words, we wanted to check to see if score is in between 0 and 100. In math, we can write something like this, right? Check if see if score is in between two numbers. But a computer is only binary. And this is one of the main limitations of a computer and why sorting requires so much work inside of a computer is because a computer can only see two things at once. It can only compare A to B. It can't compare A to B to C. That's too much for it. Okay, it can only compare two things at once. So when you want to check to see if score is, you want to compare these two things, and then you want to compare these two things. So you want to compare score to 0 and then score to 100. You have to do it separately with two separate Boolean expressions. Okay? Because it can only compare two things at once. So how do we write something like this? We want to see if these are both true. You connect them with the AND operator. So the AND operator checks to see if this is true and this is true. You see how this was our first Boolean expression, this is our second Boolean expression, and we connect them with the logical AND operator. So looking back at that truth table, this is our first Boolean expression, this is our second Boolean expression, and this is the results. And notice that it's only true when they're both true. If either one of them are false, or if they're both false, then of course our Boolean expression will return false. Now the AND operator is actually written in Java with the ampersand, and that's located above the number 7 on your keyboard. All right. Now let's look at the OR operator. The OR operator works upon two Boolean expressions the same way. So when is the OR operator going to evaluate to true? If either one of the Boolean expressions is true, then the result is true. The only time it's false is if all of them or if both of them are false. So if both Boolean expressions are false, then it's false. And then last but not least, our NOT operator turns true to false and false to true. So the NOT operator just switches it from false to true or true to false. Okay, let's look at an example of our OR. Now the OR operator is written with a line and a line. So in Java it is written with a line and a line, and you might look at your keyboard and wonder where that key is on your keyboard. But he is located underneath the backspace key, right above the backslash. If you hit Shift backslash, and it looks like there's a line, like a vertical line and then a hole in the middle and then another vertical line underneath it. But when you type it, it will make a line and a line without that hole in the middle. Okay. So that line and that line together make your OR operator. So two of those lines. So the OR operator works such that if this is true or this is true, then the whole thing is true. The only time it can be false is if they're both false, like this example here. So remember when you read these things, you can just plug in your numbers. So I just say something like, is 3 greater than 5? Nope. Is 3 less than 10? Yes. So that makes the whole thing true. Here I switch the less than to a greater than symbol. So of course this one's still false. This one still is now false, which makes the entire Boolean expression false. Okay. And then last but not least, our negation operator. It's usually placed on the outside of a Boolean expression, and it just switches it from true to false or from false to true. Now, is it not true that programs which do not use the NOT operator are not easier to read? So this is kind of a rule You always usually try to write your Boolean expressions without using the not operator. Sometimes it makes logical sense to use the not operator, but a lot of programmers will strive not to use this because it makes your program clearer if you don't use this a lot of times. Okay. All right, looking at our equals operator. It's appropriate for determining if two integers or characters have the same value. But a lot of textbooks will tell you, and a lot of tutorials will tell you, it is not appropriate for determining if two floating point values are equal. Because remember, a lot of times in our computer, when a computer translates a decimal number with a fraction into binary, usually there's some type of error. Not usually, but sometimes there is some type of error. So even though that this might be true outside of the computer, when you plug it in, he'll mistakenly say it's false. Now, does that mean I've never seen a program that uses floating point numbers inside of a Boolean expression? Yes, I've seen programs that have it. Okay. But usually try to do it with integers or with characters. We haven't gotten into objects a lot in here, but just note that if we had two strings in our program, you guys are familiar with strings. We wrote hello world. If we had a string type object, and we're going to get into more strings next week, but note that you don't use the equals operator with strings. You do use a method to check if two strings are equal. So to see if these two string objects were equal, you would use this method, and he would return true. All right, let's see if we can do this. Or actually, I'll do it for you guys. You guys don't have to do this one. Check to see if the number inputted by the user is less than or equal to 5 and greater than 0. So how would I check to see if something's less than or equal to 5? So less than or equal to 5, right? And greater than 0. So do you see how you just kind of take your words, especially when they're spelled out like that, and you just kind of write it out? That makes sense, right? What if we wanted to say, check to see if a number inputted by the user is less than or equal to 5, or is the number 10? Hopefully you're doing this in your head. Well, you put the or operator in there. And you said is the number 10, which means it's equal to the number 10. Now, is that ever going to be true? Well, yeah. If I typed in, let's see what values would make this statement true? Well, obviously, if I typed in 10, he would be true. Or if I typed in 5, 4, 3, 2, 1, or any negative number, it would be true. Or even the number 0 would make this true. Because an or statement, only one part of it has to be true. Okay? We'll get into strings, like I said, next week. So I'm going to skip the string ones because we're going to get into strings next week. All right. Now, we looked at if and we looked at if else. What if you had more than one decision to make? What if you wanted to see if a value equaled different numbers, like 1, 2, or 3? This is how you would write it. You could write it with an if, else if statement. Okay, so here we're checking to see if x is equal to the number 1, and if it is, we print out x is 1. Now what's important to know about if-else if statements is that only one path is taken, and once that path is taken, it gets out of that branching statements. So let's say x is 1, and this comes back as true. Okay. It would go ahead and it would print out x is 1. Then it would skip all the way to the bottom after this, and it wouldn't check any of these other branching statements. So you remember, once one branch comes back as true, It doesn't bother checking the rest. It makes it very efficient. Okay, because once one of them's true, you don't want to check the rest. So it's a very efficient way to check something is using an if-else-if statement. Okay. So same thing, what if x was 3? It would start up here, it would check if it's 1, it would say false. It would check if it's 2, it would say false. When it checked if it was 3, it would say true. It would print this out, and then it would skip the else part. Yes, question? For an array? You mean checking an array? I wouldn't get mixed up with arrays right now, but if you wanted to check with an array, you'd wrap this in a for loop and you could check the values of an array like this too. You could use the same kind of branching statement. But note that this is kind of like you've come to a fork in the road with 1, 2, 3, 4 different paths you could take, and you're going to take one of them. Now, can you only have 4 paths? No, you could have 10,000 paths if you so wanted, 100 paths, 10 paths. Okay, you can have as many as you want. Okay, another thing about the if-else-ifs is you could leave the else part off too. You don't have to have an else part. Okay, so you could leave that off. But a lot of people will put the else part as kind of like the default. So if none of the paths are taken, this is like your default path. Okay. Now each else is paired with the nearest unmatched if. If used properly, indentation communicates which if goes with which else. Okay, and braces can be used like parentheses to group your statements. All right, let's look at this slide here and figure out what it's doing. And I know these aren't very good variable names. Okay. But let's just plug in the numbers. And we have 2 different forms. Notice that this is the same code as this. The only difference is this one has curly brackets right here. So I plug in my numbers. If 1 is greater than 2, which is false. So where's my code going to go when this is false? Yeah, it goes to the else part. It goes to my else part. And it sets G equal to the number 8. So when it prints out, E will still be 5, and G now will be 8. Now let's look at this form. If I plug in 1 here, and then I plug in 2 here, this will be false. Where do you think it goes? It's good you guys didn't say the else part, because it does not go to the else part. It actually goes it goes past these lines of code and goes to the system out print line. And do you see why it doesn't go to the else part? When I did not put the curly brackets in, this else part bonded with this if. You see how this if and else are now hooked together? They're bonded. They're the path that you can take. Even though I didn't indent correctly, that else is still with this if and not with this if. Okay. All right. So we learned if statements. We got if else. We got if else if. Okay. And then we have switch. Switch statement does the same thing as an if else if. In fact, you can use a switch or an if else if the same way. You can go from one to the other. Some if else ifs won't translate well to switch. But a switch statement is a multi-way branch that makes a decision based on an integral, that means int, integer, or a character only. And of course, the switch can be used in place of any if-else-if statements. Now, it's not really that different from an if-else-if, but they are used because it can make your code more readable. That's why people use switch statements. And let's look at one to figure out how it works. So this example was from actually our older text, but it's still a very good example. So in this code, we ask the user to enter in the number of babies. And then we take that input in as an integer. Remember that switch statements can only work with integers and characters. And then this is what our switch looks like. It has the keyword switch and then parentheses. And what goes in the parentheses is what's called your controlling expression. But what goes in the parentheses is that integer or that character. So in this case, it's our integer. Now inside of our switch statement, we have these things called cases. And what we're doing is we're checking to see if this integer number of babies is equal to 1, or equal to 2, or equal to 3, or 4, or 5. And if it's not equal to any of these cases, then it goes to the default case. So it's like having an if-else-if statements. And this would be our else part down here. So looking at this example, if the user typed in, let's say, 1. So 1 is stored inside of number of babies. So we switch on the value 1. So it goes to case 1 and it says, yes, that's my case. It finds the number 1 and says, yes, number of babies equals 1. It prints out congratulations. And then it finds the break statement, and the break statement gets me out of my switch. So when you see the word break, it says get out of the switch statement, you're done. So all it will print to the screen is congratulations. Well, let's run it again. We'll run it with the number 3. That means the user types in the number 3 and number of babies is 3. So when it's a 3, case 1 is false. Case 2 is false. Case 3 is true because number of babies was typed in as 3. It'll print out wow triplets, and then it sees that break statement. It breaks me out of the switch, and I'm done. That's pretty much the same, right? Now here's where it works a little bit differently. It works differently when we don't have a break statement after a case. If the user types in 4, it'll go and it'll find case 4. But note that there is no break statement here. So what it'll do is it'll start executing case 4. And what it does is it ignores all the other cases and it executes all the lines of code it reaches until it hits the break statement. So note that it keeps on moving down and it executes all the lines of code, so it's actually going to print out unbelievable. It's going to print out print 4 babies, and then it finally reaches the break statement and leaves. So that's the number one thing that is a little bit difficult to understand in a switch statement is when there is no break statement, then you just keep executing lines of code until you hit that break statement. But note that in this program, they liked it to work that way because they'd like to say unbelievable if they had 4 or 5 babies. So you'd write unbelievable and then the number of babies. So if they typed in 4 or 5, you would print that out. And then in the last example here, they typed in the number 6. And you guys see what 6 does? 6 is not equal to any of our cases, and so it goes to the default case. So if you check something and none of them equal any of your cases, so your integer doesn't equal any of your cases or your character doesn't equal any of your cases, it will go to your default statement. What if you don't write a default statement? Your compiler's not going to care, but then you're not going to know what to do if none of those cases are reached. Now when we learn branching and we're doing some error checking, sometimes our program will want to stop our program from running in case, if the user types in, like, let's say a 0, and we don't want to divide by 0 error to occur, or for whatever reason we want our program to stop working. If you ever want to end your program early, then you can use system.exit 0, which is not a very elegant way to stop your program from working. Okay. Later on, as you get better at programming, you'll learn that this isn't the best way to stop your program from working. But it's okay for now to stop our program from working using system exit 0. Now I know in our first slides, I think, wasn't it in our first slides we went over these errors before? But I thought I would review them. So an error in a program is called a bug, and remember that we have 3 types of errors in our programs. We have syntax errors and runtime errors and logic errors. And we've all got lots of syntax errors as we started programming, right? Then when we forget our semicolon. One of the biggest syntax errors I see, and I saw it even today in my second level programming class, is people will put a semicolon at the end of an if statement. What if I put a semicolon right there? Notice that I do not get any kind of red underlined error. Everything seems okay. And actually my program will run. If I ran this thing and I typed in something. But what is it doing? Can you tell what it's doing? What if I typed in 89? That Boolean statement should be false, right? So what's happening is, this is how my program code is working now. It's saying, if this is true, do this line of code. And what does that line of code tell you to do? Nothing. And then when you're done with that, go out of your branching statement and do this line of code. So this is one of the number one, and actually that's not a syntax error then. What would this be? It's a logic error. Okay, it's an error in our program. It doesn't keep it from compiling, and it doesn't have a runtime error. It just gives us the wrong output. So one of the number one things I see wrong is never put semicolons after Boolean statements. It short circuits them. I call it short circuiting your if statement. It makes the if statement pretty much do nothing, whether it's true or false. Huh? Don't ever put a semicolon right there. A lot of people think, oh, semicolons everywhere, because we've gotten used to it, right? Writing all our statements. We always need semicolon, and a statement. But when we do that, it makes our if statement work like this, which tells it, hey, if I'm true, do this, which tells it do nothing. So it short circuits our if statement. Okay, so bad idea right there. All right. So syntax errors are our semicolon errors. Our compiler tells us about those errors. Runtime errors, we got that runtime error when I ran my program and I entered in the wrong value. That was that was the right value. I entered in the wrong value. Then that's our runtime error. And then logic errors were when I had that semicolon right here. That would be a logic error. Now which ones are the hardest to find? Do you guys remember? These are really easy to find. Yeah, the logic error is definitely the hardest to find. Okay. All right. So we've learned about some Java branching. We learned about our Boolean statements, and then we learned our switch. Oh, and I did stick one last slide in here. Just remember to name your variable names good variable names. Okay, as I'm getting your homeworks graded. I might yell at you for this, and if I say, hey, name your variables better names, remember I mean names better than X, Y, or Z. I know some of my slides have A, B, and C as variable names, but in your programs you turn into me, always name your variables good variable names, starting with a lowercase letter, okay, and following the rules for good variable names. All right, so that kind of concludes our lecture here on branching. Any questions on branching?